Rolling or sliding window iterator? I need a rolling window, aka sliding window, iterable over a sequence/iterator/generator. Default Python iteration could be considered a special case, where the window length is 1, I'm currently using the following code. How can I do it more elegantly and or efficiently? For the specific case of window_size equals to, i.e., iterating over adjacent, overlapping pairs in a sequence, see also iterator list as pair, current, next, in Python.
There's one in an old version of the Python docs with itertools examples. The one from the docs is a little more succinct and uses itertools to greater effect, I imagine. If your iterator is a simple list/tuple, a simple way to slide through it with a specified window size would be output.
This seems tailor-made for a collections.deck, since you essentially have a FIFO, add to one end, remove from the other. However, even if you use a list, you shouldn't be slicing twice. Instead, you should probably just pop 0 from the list and append the new item. Here is an optimized, deck-based implementation patterned after your original. In my tests it handily beats everything else posted here most of the time, though Pillmuncher's T version beats it for large iterables and small windows. On larger windows, the deck pulls ahead again in raw speed. Access to individual items in the deck may be faster or slower than with lists or tuples. Items near the beginning are faster, or items near the end if you use a negative index. I put a sum w in the body of my loop. This plays to the deck's strength. Iterating from one item to the next is fast, so this loop ran a full 20% faster than the next fastest method, Pillmuncher's. When I changed it to individually look up and add items in a window of 10, the tables turned and the T method was 20% faster. I was able to recover some speed by using negative indexes for the last 5 terms in the addition, but T was still a little faster. Overall, I would estimate that either one is plenty fast for most uses, and if you need a little more performance, profile and pick the one that works best.
I like T. Gives.
There is a library which does exactly what you need.
If you want to see more, please consider subscribing.